GTC 2026 was dominated by agentic AI frameworks, particularly the NemoClaw and OpenClaw orchestration tools, drawing the largest attendance of any sessions, with Fortune 500 companies announcing production agentic deployments across manufacturing. This marks a significant shift in enterprise AI adoption, moving beyond experimental phases to production-grade implementations. Agentic AI systems can autonomously perform complex tasks with minimal human intervention, enabling organizations to scale operations more efficiently. The widespread enterprise interest demonstrates the maturity of these technologies and their immediate business value. These frameworks are revolutionizing how companies approach digital transformation and process automation across multiple departments. Cybersecurity researchers disclosed an automated campaign called Megalodon that pushed 718 malicious commits to 561 GitHub repositories within a 6-hour window, using throwaway accounts and forged author identities to inject GitHub Actions workflows containing base 64 encoded bash payloads. This massive-scale attack represents a new level of threat in software supply chain security, exploiting the trust developers place in automation tools. The attackers demonstrated sophisticated understanding of CI/CD pipelines and cloud infrastructure, targeting the most sensitive credentials used by development teams. Organizations using GitHub and CI/CD systems are now facing heightened risk as attackers evolve their tactics to maximize impact across multiple targets simultaneously. The incident highlights the critical need for enhanced monitoring and security validation in development environments. Texas sued Meta and WhatsApp for falsely claiming messages are encrypted while allegedly accessing private communications, highlighting ongoing concerns about corporate privacy practices and misleading security claims. This lawsuit represents a significant challenge to major tech companies, privacy narratives, and marketing practices. The case raises important questions about the true security of widely used communication platforms and whether companies are being transparent with users about data access. Legal actions of this magnitude can drive industry-wide changes in privacy practices and corporate accountability. The lawsuit underscores the growing scrutiny that technology companies face regarding their security claims and actual implementation. Microsoft announced a 4-year, $10 billion investment in Japan, spanning 2026 to 2029, covering AI data center expansion in partnership with SoftBank and Sakura Internet, deep cybersecurity cooperation with the Japanese government, and a pledge to train over 1 million engineers and developers by 2030, mapping directly to Prime Minister Takaichi's sovereign AI strategy. This major investment reflects the strategic importance of the Japanese market and Microsoft's commitment to localized AI infrastructure. The partnership ensures that sensitive government and enterprise data remains within Japan's borders while accessing Microsoft's comprehensive AI capabilities. This model of localized, sovereignty-focused infrastructure is likely to become increasingly common as nations prioritize data protection and technological independence. The training initiative will help build Japan's AI talent pipeline and strengthen its competitive position in the global AI market. Amazon's cloud revenue was up 63% as the provider spent $35.7 billion in capital expenditures to reap AI opportunities, with CEO Andy Jassy committing that the tech giant will continue to lay out cash for compute infrastructure, including land, buildings, and chips. This unprecedented level of capital investment demonstrates the competitive intensity in cloud infrastructure as providers race to capture AI workloads. AWS's commitment to continuous infrastructure expansion positions them to maintain their market leadership despite competition from Microsoft and Google. The massive capital expenditure reflects the hardware-intensive nature of modern AI training and inference operations. This arms race in infrastructure investment will likely continue accelerating through 2026 and beyond. After decades and billions in losses, Ethereum finally fixed the blind signing flaw, a critical vulnerability that enabled attackers to execute unauthorized transactions. This security fix represents a major milestone in Ethereum's evolution towards safer user experiences. The blind signing vulnerability has been exploited for years, with users unknowingly signing malicious transactions that drain their wallets. The patch implementation will require wallet providers and exchanges to update their systems, but should significantly reduce fraud in the Ethereum ecosystem. This development demonstrates the ongoing efforts by blockchain projects to address fundamental security issues and protect user assets. The Department of Commerce announced the signing of 9 letters of intent to provide $2.013 billion in federal incentives under the CHIPS and Science Act to support a portfolio of quantum companies, including 2 domestic quantum foundry companies and 7 quantum computing companies, to accelerate solving the most critical technology challenges in the race to develop utility-scale, fault-tolerant quantum computers. This substantial government investment reflects the strategic importance of quantum computing to U.S. technological leadership and national security. The funding distribution across multiple companies promotes a diverse portfolio approach to quantum development, reducing risk and encouraging innovation across different quantum computing architectures. Federal backing signals confidence in near-term commercial viability of quantum systems. The emphasis on fault-tolerant quantum computers addresses the primary challenge, preventing current quantum computers from solving real-world problems at scale. As industries push for more automation, the Internet of Things trend is shifting toward AI-driven IoT, AIoT, where IoT systems can process vast amounts of data in real time by integrating machine learning with connected devices, enabling predictive decision-making and autonomous operations that reduce human intervention and increase efficiency. AIoT represents the convergence of 2 major technology trends into more powerful, integrated systems. Organizations implementing predictive maintenance through AIoT can dramatically reduce downtime and operational costs by identifying equipment failures before they occur. The shift toward edge intelligence means critical decisions can be made locally without constant cloud connectivity, improving reliability and reducing latency. AIoT is becoming fundamental infrastructure for Industry 5.0, which emphasizes human-machine collaboration and intelligent autonomous systems. In 2026, the most important question about connectivity won't be peak bandwidth (euro). It will be consistency, as applications like robotics, automation, and safety systems require predictable latency and reliability, and IoT systems are increasingly shifting toward prescriptive systems that recommend actions on top of just predicting failures. This paradigm shift reflects the maturation of IoT from novelty to critical operational infrastructure. Modern prescriptive systems now consider labor availability, spare parts, production schedules, and cost trade-offs, moving beyond simple predictions to business-focused recommendations. The integration of AI and IoT creates systems that can perceive, reason, and take action in the physical world with minimal human involvement. Reliability and predictability are now more valued than raw performance, reflecting real-world deployment requirements. T-Mobile and Ericsson trialed an AI-native scheduler with link adaptation using customer traffic on T-Mobile's 5G Advanced network, with T-Mobile planning to deploy the technology commercially in the third quarter of the year, leveraging an AI-RAN alliance with NVIDIA and Nokia to supercharge its network. This AI-native approach to network optimization represents a fundamental shift in how 5G networks manage spectrum and user connections. By embedding intelligence directly into RAN software, T-Mobile can deliver real-time performance gains that enhance user experience while maximizing spectrum value. The AI scheduler learns from actual network traffic patterns and adapts dynamically to optimize performance across all users. This commercial deployment will give T-Mobile a significant competitive advantage over competitors still using traditional network management approaches. AT&T, T-Mobile, and Verizon form a direct-to-device joint venture, representing a strategic collaboration to expand rural coverage and compete with emerging satellite connectivity providers. This unprecedented cooperation among major competitors demonstrates the market opportunity in rural connectivity and the need for alternative technologies beyond traditional tower infrastructure. Direct-to-device satellite connectivity enables phones to maintain connectivity in remote areas without requiring additional hardware. The partnership leverages the combined resources and networks of 3 major carriers to achieve scalability and cost efficiency impossible for individual companies. This development represents a significant shift in how major carriers approach coverage expansion and competitive positioning in an evolving telecommunications landscape. Thank you for watching. Please do like and subscribe for more content and stay updated with the latest technology news.